We're often asked what levels of vibration amplitude can be measured using VibVue. Contrary to what we're all used to with other vibration measurement sensors, the answer is, it depends. Let's take a look at what it actually depends on. Fundamentally, it helps to think about the camera's light sensor as an individual pixel instead of the camera as a whole. This tiny light sensor, along with all its neighboring sensors, feeds dynamic light information back to the camera. The camera processes all this information and sends it off to a computer as image files. At this point, the VibVue magic goes to work. In this video, we'll focus on how this pixel drives the amplitude detection capability. Each pixel is a square with certain dimensions and one gray value, somewhere between 0, black, and 255, white. Each pixel monitors a discrete portion of the object you're measuring. If the overall image is looking at something 3 meters or 10 feet wide, and you're using 1,920 pixels across that 3 meters, then each pixel is covering approximately 1.5 millimeters in length. Kudos if you did that math in your head. And remember, the pixel is a square, so it's covering the same height. If you look at something 30 meters or 100 feet wide, that same pixel would cover 15 millimeters. And if you look at something 30 centimeters or 1 foot wide, that's right, 0.15 millimeters. This overall width of the image is what we refer to as field of view, and it gives us a reference point to base our pixel level amplitude detection on. With the field of view as a reference point, it now becomes a question of how well that pixel can perform. This is a function of several factors. 1. The quality of the camera sensor. A noisy sensor creates a high noise floor for the signal and makes it difficult to detect low levels of vibration amidst that noise. That's why we chose the best performing cameras at a reasonable cost for our VibVue and VibVue high frequency cameras. 2. Lighting and contrast. This is a light-based sensor after all, and you'll need a lot of light to solve problems, especially at higher frequencies. We also like to use specialized high-contrast targets we developed to make the signal even better, which we've included along with the lights in our VibVue packages. And 3, the most important factor, the algorithm. This is where VibVue really shines, quickly detecting low-amplitude vibration for both displacement measurement and magnification. VibVue can magnify anything you detect from the FFT. If you can clearly see a signal on the FFT, we can quickly show you clear, motion-magnified video at that frequency. No resetting the camera for a close-up and losing the comprehensive view you've come to love and rely on. So, back to the question. How much amplitude needs to be there in order for VibVue to detect, measure, and magnify it? As we know, field of view matters when detecting amplitude. If someone tells you video vibration amplitude detection capability without the field of view, or talks about lenses or distance from the object, you now know why it's important to ask for clarification. We'll use a 3 meter or roughly 10-foot field of view as our reference, measuring peak to peak. Since the camera sensor plays a critical role in detection, our 2 cameras, one for lower frequency problems and one that handles high frequency problems, have different detection levels. The VibVue camera can detect down to 2.5 microns or 0.1 mils peak to peak for that 3 meter field of view. And the VibVue high frequency camera can detect down to 5 microns or 0.2 mils peak to peak for the same 3 meter field of view. We know! We think that's pretty amazing too. Check out some of our other videos, like what the frequency range depends on, to learn more about VibVue. And if you would like help solving your rotating machinery problems, or would like a VibVue system of your very own, don't hesitate to contact us on our website at mexsol.com.